Hello folks in MAT-114. Welcome. We are for sum of 1. You guys, I believe, officially are MAT-114 INC1. Anyhow, the topic of today, which I'll have a tendency to put over in this corner, is section 4.1. Here is the calendar that I drew up yesterday. This is posted online. These numbers that you see on the calendar are the section numbers, so those are the topics that we'll be covering on the respective days. Today is Tuesday, May 18th. All right, so we'll be covering that. I'm going to do a little introduction as well. I'm sorry for the hiccup yesterday. I really wasn't counting on the class running, but I'm grateful that it did. Right. Work is work. So thank you. Let me show you a couple of things. There's a packet that I put together every day that you can download. I try to make them in color, but if you have a printer of any sort, that would be sufficient. Today's would look like this. This is an overview basically of chapter 4. And I left a little space here in case you wanted to fill in some information. And we'll keep coming back to this diagram basically for the next the subsequent 3 sections, so you could add information. It's to sort of have an at a glance. This is a diagram I use all the times when we have vocabulary, as we would today. Just to summarize, right, some terminology. If there happens to be a mathematical symbol, maybe put it adjacent, and then we'll give it a description. Whatever the term is. This is very important. I swiped this basically from the textbook. Which is an ebook, by the way. You could get a hardcover book. Looks like that. All right. Most likely, though, if you are utilizing the MyLab software, the ebook is automatic. Anyhow, I try to make those things available so you don't have to go digging. This diagram is basically a key, or several keys, of what the different systems of numeration correlate to in our standard system, otherwise known as Hindu Arabic. So when you're doing your work, even in MyLab, you probably would want this out of everything because it will translate or help you translate. And then there are some more in-depth descriptions and some activity I'll do with you to summarize the systems that we will go through here today. One of the 4, and eventually there are the actual examples that I swiped from the book. Now, because they're pretty alien, I also left the solutions here, so you don't actually need me, you just need your own 2 eyes. But I'm going to go through several of these. Okay? All right, so if you're following along, do try to print that out, and we'll go over this in a few minutes. Let me just steer you in the right direction. Where are my glasses? I'm in my house, by the way, so if you hear any knocking, they're renovating next door. Turn the projector on. I probably have to adjust my camera. But I have a little dinky $50 computer projector that I'm going to use to superimpose here. And adjust the lights as necessary. You're in my kitchen. Okay. And I'll move this over slightly. It doesn't look too blurry. Doesn't look too clear either. Looks like somebody moved it. And it wasn't me. Alright, that will suffice. Okay, I assume most of you are probably second-year students here, but if you're not, basically once you navigate to the Middlesex homepage, there is a tab at the very top that says My MCC, which I have to assume is going to change to just 1C eventually. But anyhow, My MIC. And then you would navigate over to where it says Canvas. I'm already logged in, at least I hope I am. This is what my end of it looks like. I tried to make the tile obvious, so I made this sort of bright, magenta color, I guess it is, or maybe it's violet. Anyhow, in here, there's really a couple of tabs that I use on the regular. So I tried to limit it to that. Let me just adjust this if I can make it a little bit sharper. That's not too bad. Alright. You know what? I'll show you the student view. This is probably less congested here. Alright, when you open it, it should basically have this column of options here. What I use are the things that I stacked on top. Alright. Home is really the syllabus page, so automatically that. So if you clicked on syllabus, it would take you to this anyway. All right, and the syllabus is, here's the copy of the official syllabus for the class, the PDF if you'd like to look at it. All right. I utilize announcements virtually every class because I put links there. My lab and mastering is where you would have to navigate, all right, to either establish the homework or just going to do it. All right, now this is the student view, so it's a little bit different from my view, but anyhow, you would basically navigate to this, click on My Lab and Mastering if you have no account, right, or if you have an established account already, and then pay for the software basically. So you hit accept and go beyond that. Anyhow, you can likely purchase the software from the bookstore. If you do that, just hesitate a little bit because they're supposed to send you an email. At least this was the issue last spring, all right, for the better part of a week or two. All right, a lot of people weren't getting their emails, so they were, not doing their assignments. Anyhow, I assume they're a little more on the ball now, but this is probably just as quick. All right, if you just go through My Lab directly. All right, the class that you would identify, I sent you the information that I was told to show you, which is the title of the class, 21/PS MAT-114 INC1 Mathematical Structures 2. Or if they're asking for something else, it's my name, Ziegler, right, MAT-114 Summer 1. I had sent you this email. There is other information, but I have been specifically told by the software company, Pearson, not to give it to you. So I'm really not supposed to give you anything else. You have to sort of fish a little bit, okay, not to be a jerk. They want you to purchase the software is what it is. All right, anyhow, the other thing is, as I said, announcements. I have just this one announcement here. The information that I'm alluding to is this. This is the course name in blue here, and this is the description of it. It should be sufficient, right? There is another piece of information that I had been given, but I'm specifically sworn not to give it to you because, again, they want you to pay for this. Anyhow, please do that as soon as possible because this is a summer class and it's very, abridged time frame, or shortened. Anyhow, this is really all that you are supposed to need, this in blue here, right, to identify our class. Okay? Anyhow, what is normal is that I post announcements here. And I'll put the date so you know what it is. So later today, after I'm done recording and I upload, I'm going to link the video for section 4.1 in announcements. Right? I believe that it automatically mails you, folks, but I'm not on the receiving end of it, so it's hard for me to say. Do look there. Right? The other thing is pages. Being that I've taught this class several times now, I have these pages established. Right? So the material that would be relevant today is chapter 4. Right? There's some stuff there already. I did make a couple of new diagrams, so I'm going to upload them again after I'm done recording. And if you'd like these, you can print them. Okay? But that's where you would go. Okay? You would go to specifically page that is chapter 4 materials. Okay? Anyhow, you have access. Right? Then your grades should be visible under the grades tab. Right? And so forth. Okay. As I promised, I gave you credit for the tests and the final already because, well, for one thing, there's not enough time for those things. So we really need to just cover the material and get it done. And you have a lot of homework assignments to do. So I made them all due on the last day. Let me show you the syllabus really quickly. Here's the syllabus. I made all of the assignments due on the very last day, which is July 1st. But you don't want to wait until then to start, right? The sooner the better. Basically, this is sort of a schedule for you as well. So if we cover section 4.1 today, do try to do 4.1 assignments today in my lab, all right, and so forth. If you make the mistake of waiting until July 1st to do all of these, you're going to be in trouble, all right, just for the lack of time. All right, anyhow. This syllabus, you don't really have to worry about it, but it does tell you, all right, the things that are mandatory. You need MyLab, the software I mentioned, and you need a calculator. I'm a dodo and I left my calculator upstairs, so I'm going to hold off on showing you that, but in the flesh. But yeah, let me show you this. The TI-30X2S looks like this. It's blue. Something like that. It basically looks like this. Not that I want you to get it from Amazon, the free advertising on Amazon. But you want to get this type. It doesn't matter what the color is, but this is the model, the 30X2S. Right? It's capable of handling statistics, which is the latter half of the semester. The chapter 12 material specifically, you definitely want this calculator. So you might be able to find an emulator, but better to have this on hand. It's only like $10 to $20. Right, on Amazon apparently it's 13. All right, so it's well. Anyhow, as you can see, it has statistics here. So you definitely want to get that. All right, the material that we're going to cover is chapter 4, 6, 7, 8, and 12 in that order. This is the ISBN if you want a physical copy. I'm a little old-fashioned. I do like to have a physical copy of the book, but not required to. All of the assignments are in my lab. All right, and again, this is the identifying information with my name. All right. There are other things in here, but they're really not important aside from the scale and how I'm going to grade you. All right. Basically, the front page and what would normally be the back page is the most pertinent information. As you can see, my lab is half of your grade. All right, so you don't want to skimp on that. Again, being of the situation that we're in, which is we have a consolidated amount of time, shortened, and the hiccup yesterday, I'm just giving you credit for this. So you are starting basically from 50, all right, rather than 0. All right, that's not passing, of course. You need to do some work, but where are you going to learn to do it? As with any person, you learn from doing the homework. All right, don't let anyone dissuade you. All right, so I've made that the most important thing. We're also on home instruction, so that's really the best way to go about the class. All right, I have a test and I can give it to you, and I have a final I can give it to you, but I want you to focus on this. Okay, all right, that's your grade, and here's the grade scale. Okay. All right. As for what the section numbers actually stand for, again, the back page is what would be useful to know. Section 4.1 are these systems of numeration: additive, multiplicative, and ciphered. All right, and then 4.2 positional systems, and you can see the whole slew of them here. Okay, this is a normal 29-day schedule. All right, presumably in fall or spring, but I'm taking the days out that would be the test days because again, we're short on time. So make sure that you get your software, your homework together, and you'll be fine. All right, there's some other information in here if you'd like. Just please regularly check the course announcements if they aren't automatically mailed to you. There's 33 My Lab assignments, and that's primarily what you're responsible for. Okay. Go back here. Do that. All right. Again, here's the syllabus if you'd like to print it. We'll do a preview if you like. We're not meeting at any specific time. We're just meeting on quote unquote. We're having class on Monday through Thursday, as if we were in person. All right. If you want to ever know where we should be, and I have to pretty much stick to a rigid schedule, just look at this hand-drawn calendar here that is on the home page. All right. Intro yesterday, basically, and today 4-1, and that's the schedule. Okay. All right. Let me turn this off now and mosey on down here. Okay. All right. Let me start with the terminology first. Since we're talking about systems of numeration, if you want, you don't have to do this, of course, but make a little border in your notes if you're handwriting anything. Just fold over the two edges of the page and make a little border for chapter 4. All right, so this will be systems of numeration, chapter 4. We're doing 4-1. All right. Now, as I mentioned, I'm going to use one of my things here. I'm going to close the other door. This is too bright. My sister is also working, so you may hear her voice in the background. And she talks to people on NJ Transit, so they're a little hard of hearing with the trains. All right. Okay, let's get through this. All right, let's start with the few pieces of terminology we have, and then I'll go back to my diagram. All right. Being that we are talking about systems of numeration, there are 3 words or phrases that we should know. All right, this may sound silly, but the word number, all right, needs to be clarified. All right, a number is a quantity an amount of something. Right, answers the question of how many. Right. And you might go, well, that's silly, but we all know that. Understandably so, but there's a similar sounding phrase, and it's important that we have this established. All right. The next thing that is similar sounding is numeral. Right? They're not exactly the same thing. A numeral is the actual symbol. Used to express the quantity or represent it. This is abstract. This is the actual, more or less concrete things. It's a drawing. Okay. And then there is this phrase, right, which is not coincidentally the name of the chapter. System of numeration. Basically, a system of numeration is a set. If you remember from MAT-114, if you've had that class already, I don't think you have to take them in sequence, but I'll assume that you had seen MAT-113. And in which case, early on, the subject of sets came into play. Right? A set is basically a container of numbers or something like that. Elements would be the phrase of choice. Anyhow, a system has a set, right, of numerals. The drawings basically represent the concept, and a scheme for combining them. In order to represent quantities. So a system of numeration, which we are discussing, is a set of numerals, the actual drawings, and a scheme for combining them in order to represent quantities. Right? So we have the actual numerals and how you would make them into, use them to describe actual, well, abstract numbers, amounts of something. Okay, there's a very pithy quotation that I like, which summarizes this perhaps better than even I could. Probably can. This is, you give credit where credit is due. On page 164, right, you could distinguish this concept from this concept, number from numeral, in this way. We think a number. But we write a numeral. That really gets at the heart of it. Okay? Just to emphasize here, we think a number, but we write a numeral. Thinking is abstract. Right? When you write something, that is essentially concrete. Right? It's an actual thing when you write. It's something done in reality versus in the mind. Okay? So having gotten the terminology out of the way, and we know what we're up against here, let me show you the overview that I prepared for today. This is a new slide I have never used before. I made this yesterday evening. And let me erase the gobbledygook here. I know, because the blue ones are always very sticky. I have to press a little hard to get rid of it. Anyhow, I like to make these diagrams because I hope that they are enlightening, right? This is essentially chapter 4 in a nutshell, right? We're dealing with systems of numeration as described, a set of numerals specific to the system, right? And the scheme for combining them to represent numbers. There are essentially this first dichotomy here. There are ancient systems which we're going to describe, and then there are the modern systems. Now, the system that we use, right, which looks like this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, is known as the Hindu-Arabic system. Right? A lot of times this is shortened in English-speaking portions of the world. They will call it somewhat of a misnomer, Arabic numerals. Why? Because Europeans basically got them from North Africa. Right? They probably originated in India, right? And stylistically, the shape of these numerals changed over time, but they actually originated in the very far east. Right? The style of writing them is probably closer to Arabic. Anyhow, let us give credit where credit is due. Right? The goodness of algebra and of usage, the popularization of Arabic numerals, Hindu Arabic numerals, right, is from the Middle Ages. Right. and specifically from North Africa. Anyhow, these this is a little bit more recent in time, all right, the usage of these. And the modern systems that we'll be talking about when we get to essentially section 4.3, all right, include but are not limited to the binary system, the octal system, and the hexadecimal system. These are brought up first out of the many that are possible because they correlate to computer language. All right. You probably heard of binary code, and whenever they try to illustrate the idea of computer language, a lot of times you'll see zeros and ones. Well, that's referring to binary, the most basic communication with the computer. All right. Basically, 0 or 1 represents a transistor either having a voltage or not having a voltage. All right. Anyhow, I'm digressing. The material that we are covering, all right, today is from here to here. All right. The additive systems, the multiplicative, and the ciphered. All right. What is part of what would technically be ancient systems is positional, but this is section 4.2. Right. We are doing section 4.1, so we're going to be talking about these specifically, additive, multiplicative, and ciphered. Now, we have examples of basically all three, 2 of the additive system, 1 of multiplicative, and there are others, of course. All right, and 1 example for ciphered, the Ionic Greek. So, Egyptian hieroglyphics, believe it or not, right? Roman numerals, which are maybe more familiar to an American, traditional Chinese, and Ionic Greek. All right. Section 4.4, which is not here, utilizes these systems, the positional systems, in arithmetic. So adding a binary system, adding in an octal system, adding in a hexadecimal system, right? We'll cross that bridge when we get there, right? But right now, our focus is 4.1, additive, multiplicative, ciphered. All right, now to summarize these, let me give you some basic information. When it comes to the additive systems, both of these, and I'll try to emulate the heading here. Symbols are basically repeated to convey an amount. Right? In either Egyptian hieroglyphics or in Roman numerals. Right? To distinguish one from the other, I don't know if green is going to show up here, so we'll take our chances. The distinction between these two, in the case of Egyptian hieroglyphics, that's I wish green would work. It never does. That's a different marker. That's better. Right. In the case of Egyptian hieroglyphics, the order doesn't matter. Right. 2 different arrangements can refer to of the symbols can refer to the same quantity. In the case of Roman numerals, order very much matters. Not odor, that's terrible. Order does matter. So you're going to see that distinction early on when we do some examples. Just to give you a little tidbit of information about the multiplicative system, the example that we have of a multiplicative system in this book is traditional Chinese characters. So, if these are some key points here, symbols repeated to convey an amount of something, and in which case the order matters, what doesn't, does. What is very important in that as a Westerner that you need to get used to, including myself here, the symbols are not written horizontally. All right, the symbols are stacked. vertically. So be prepared for that. Okay, that's interesting. When it comes to Ionic Greek, because I'm short on color distinctions here, I'll put this key point here. They're basically using letters to represent numbers. Rather than have distinct symbols, like we use these symbols specifically to represent the concept of numbers, but in a ciphered system, they're using the established alphabet, in the case of Ionic Greek, the old, very old, ancient Ionic Greek alphabet, to represent quantities, right? So one thing stands for something else. You need a key in order to, memorize a lot of stuff in order to figure it out, right? So we're going to talk about basically these four systems, and I'm going to give you examples of each. Do save this piece of paper if you have it printed, because we'll come back and fill it in over the course of the week. All right, so by Thursday, we'll have gone through section 4.3 here. All right. And do, especially, you want print this key or group of keys, because it will make your life a lot easier. Definitely want that when you're doing your work. All right, now let me give you some more information about these individually, right? We'll fill in some of this together here. All right, ancient Egyptian hieroglyphics, all right? As mentioned, the order is not important, right? Two different arrangements can represent the same quantity, right? So you might see, if you were a scribe back in the day, right, you might take some sort of artistic license and put things in your own unique or favored arrangement, all right? Less standard than you might think. What does it entail doing as far as an operation is concerned? It's mostly adding, or if you think about it, not adding, all right? It's sort of a quasi form of subtraction, because what's interesting about it is that to subtract is simply to write less characters, If adding is just tacking on an extra symbol, all right? Subtracting is just removing a few, all right? It's very literal in that sense. Anyhow, there is technically a process known as duplication for multiplication and mediation for division. That's from section 4.5. You are not responsible for that. Okay. These two things would be in section 4.5. Not responsible for that. Okay, so don't worry about that. We're just going to be basically adding or not adding. What distinguishes the Hindu-Arabic system from many of the other systems, most of them, is that the Hindu-Arabic system, which I'll abbreviate as H-A, has a symbol for 0. Right? That is very important. Right? These other numbers are great, 1 through 9, but in order to do more complex math, at least in a decimal system as we have, 1 needs the symbol for 0. Right? The Mayans had a symbol for 0, and the traditional Chinese characters have a symbol for 0, but these other ones don't. Right? I guess in their mind, if you think about it this way, if a 0 represents the concept of nothingness, then why would you have a picture to draw that, to represent that? It would be kind of silly in their minds. Well, in order to do something like we do algebra or something more complicated, it definitely comes in handy having that. Reciprocals, which are essentially fractions, all right, are implied in tandem with this sort of circle-esque looking shape. So, as an example, if you had something that looks like this, A table, sorry, right? Three-legged stool. Right. This is a symbol for one, just repeated, iterated, and the circle above it. It means the reciprocal of 3. Right. So the reciprocal of 3 would be basically 1 over 3. Right. That concept, right? A fraction. Essentially, the system employs powers of 10, all right, without really getting into it. I have a blank table, and I figured that what would be practical is, since it's ancient Egyptian hieroglyphics, how many people will communicate that way anymore? We'll fill in the table together, so it's an activity that will help you remember. So here's that table, and it's purposely blank. The Hindu-Arabic power of 10, if these are powers of 10, remember, are base 10, and then an exponent, technically. So 10 to the 0, 10 to the first, 10 to the second, 10 to the third, to the fourth, to the fifth, and to the sixth. That's a 5, I swear. This is how you could represent what we would think of as the number 1. Right? Might seem silly, right? But you could verify with your calculator, just not to get into the reasons why. Quotient rule of exponents. But 1 can be represented as a power of 10, technically. One example of 10 would just be 10. 10 to the second is 10 times 10, which is 100. 2 zeros, same as the exponent. 3 zeros, 1,000. 4 zeros, 10,000. 5 zeros, 100,000. 6 zeros, 1 million. In the United States, we have a tendency to use commas on the left side of what would be a decimal, right, to separate whole numbers from fractions. All right, so we have a comma every 3 usually. In the case of 1,000, you really should put a comma here, but often textbooks do not because it's considered more confusing to look at. So stylistically, you might just see something like this, even though every 3 you put a comma. All right. Anyhow, the ancient Egyptian hieroglyphic equivalent of 1 is very intuitive. Right? It looks just like 1, right? Which probably itself is derived from a finger, I would guess. If, our ancestors probably started with math by using their hands, right? If not their toes, too. This is intuitively the amount of 1, right? As you look across this table, you will notice that symmetry amongst the different systems, right? Here is ancient Egyptian hieroglyphic for the concept of 1, right? Here's ours, all right? Roman numerals use an eye, which again is a slender, shape. And in traditional Chinese, it's just the same idea. It's just horizontal more than it is vertical. All right, they stack these ways. Okay. Now, what is this referred to as? Well, in English, it's thought to be a staff. The amount of 10 is this shape, right, which is referred to as a heel, right, or an arch, right. I would guess that it's something like a person's, the heel print in, like in the beach, on the sand. Not sure why that is decidedly 10, but hey, so big. 100 is a scroll in profile, so it's scrolling on its edge. Right. 1,000 is this shape, which to me looks like a fire flower from Mario Bros. Somehow. sort of a downward pointing arrow into a pot, and this is supposed to represent a lotus flower. Right. When you get to 10,000, this is a literal pointing finger. A 100,000 is, it looks something like a Jesus fish. It's actually thought to be a tadpole. And this, my favorite one out of all of these was, it just tickles the hell out of me every time I think about it. There is a little picture of a person looking a little bloated here, all right, with their arms raised like this. This is a little person, all right? It's referred to as astonished person. Astonished as in greatly surprised, right? Astonished person, you know. Meanwhile, what is it affiliated with? The quantity of 1 million, all right? It's as if the idea, the concept of a number that large just blew the ancestors' minds, right? You know, they're like, so much grain, you know. It's amazing, right? I mean, if I won the lottery, I'd be pretty happy too, right? But, and I will make that gesture if that ever happened. Astonished person. Let's go through the Roman system now, and then we'll do some examples. All right. There's the next slide here. If you went to Catholic school, chances are, and I would not assume that one way or another, but if you did, very likely you were taught Roman numerals, right? Just for traditional reasons. It is still incorporated on buildings. A lot of times you notice that one of the cornerstones has the date that the building was constructed, but they use Roman numerals. At the end of a movie in the film credits, a lot of times you'll see the date of the copyright in Roman numerals for whatever reason. All right, and they are somewhat intuitive, right? As I mentioned, Roman numeral 1 is something like a finger, just as in the case of you know, this sort of shape of 1, as in the ancient Egyptian hieroglyphics, right? The V is the 5, right? Which to me, the logic would be if you're sticking with your hands, and our word digit probably derives from this anyway, all right, literal digits, all right? That's more or less the outline of your hand. An X, well, what is an X? That's like having a V stacked on top of a V, right? So I'm extrapolating quite a bit here, but that would be my logic. And if nothing else, it's an easy way to remember. 1 finger, 5 fingers, the outline of your hand, 10 fingers, right? 10 digits, right? A hand on top of a hand, all right? Then when you get to these other figures that they have, right, to work with, dedicated to numbers, right? They cease to represent an actual shape. Now, an L is a 50, for you Super Bowl fans, right? A C is 100. Think cents, you know, English American speaking people. D is 500, and M is 1,000. Okay. And beyond that, you would have to employ some, to get larger quantities, you might have to employ some operations. Now, in the case of Roman numerals, in contrast to ancient Egyptian hieroglyphics, remember, order is important in this case. And the reason that it's important is because it actually determines whether you add or subtract. We kind of think of ancient Egyptian hieroglyphics as really being adding, all right? Because again, it's just repeating the same symbol as many times as necessary. The problem with that is that it can make things rather long, right? There was an example I didn't mention in the ancient Egyptian hieroglyphics. If you wanted to express the quantity 99,999, you would need 45 characters. It would just be kind of silly, right? Versus just 5. All right, it's inefficient at any rate. I mean, you shouldn't laugh. Now, what we are tasked with doing, in this case of Roman numerals, is that we are mostly adding, all right? But we could also do a more formal kind of subtraction, all right? The Romans also did not use a symbol for zero. Again, to them, it would be silly to have a symbol for something that represents nothing, all right? We have a more complicated view of zero nowadays. Zero is the neutral boundary between what is positive and what is negative, right? They had no concept of integers at this point, all right? Anyhow, there are no more than 3 of the same symbol repeated in a row, right? So ancient Egyptian, you could put as many fingers as you want. You could use as many astonished people as you want, in theory. Tadpoles or what have you, fireflowers, all right, the nose. But in Roman, you can only use 3 of the same shape, same symbol, right? And we do read letters, numbers from left to right, right? What you want to kind of get in the habit of is looking for couples, all right? Because as I mentioned, the order of Roman numeral will decide whether you add or subtract. Now, here's a summary of that, all right? If you had a V and then an I shape, right? On the left side, that would technically be a 5, right? And on the left is a 5, on the right is a 1, right? When the quantity on the left, as it is in this case, is greater than the quantity on the right, you actually add these, right? And in which case you get what? 6, right? When the situation is reversed, you have a 1 here on the left and you have the 5 here on the right. When that left quantity is less than the right quantity, then you actually subtract. Now here's the thing, all right? In modern mathematics, you would never do this. You would never write 1 minus 5 equals 4, right? But again, they had no concept of integers, right? There are no negatives in Roman numerals, okay? So even though this is a no-no, this is dodo math, bobo math in our modern idea of mathematics, this is essentially how you might think about it when you're trying to translate it into Hindu-Arabic symbols, all right? It really is this. It's 5 minus 1, all right? But this is the arrangement. The 1 happens to be on the left side, all right? Just don't make it a -4, which it would technically have to be, all right? The commutative property apparently had not been established at this point, you know? And again, there's no negatives in the Roman numeral system, so this would just establish the digit of 4. Okay. All right. For quantities that are larger than 1,000, and that's not technically true. I mean, like if you had 2,000, what I mean of magnitude of, like, you know, something like, let me add to this. For quantities much larger, much greater than 1,000, right? You would use a sort of bar notation. A bar notation is when, if you had, say, a decimal that repeats, you would use this as the abbreviation, a little bar above the 3, right? Well, in their case, what we would do, or what you see, is something like this. Here's an example. C with a D over it. All right. This by itself, all right, is 100 and 500. All right, which means that the smaller quantity being where it is on the left side, and the larger quantity being on the right side, you would subtract. So you would end up with just 400, right? No bar notation. But if you had this instead, if you see instead a C, D, and then a bar over the 2 of them, right? That is telling you to multiply the quantity you calculated by 1,000. So if this much by itself is 400, then this bar is telling you to then multiply that by 1,000. Which means what? You're going to have a 4 with 1, 2, 3, 4, 5 zeros after it, which is really 400,000. Not quite astonished person, right? Because it's not a million, but hey. So beware of that. There's a little edit here, much greater than 1,000, right? At the end of modern movie titles, right, if you see the year 2000, it's 2 M's, right? Right? That should be legitimate, right? But if you're talking about something that is a magnitude higher by 10, like 10,000 or greater, right? Beware, right? Bar notation is something you might see. Okay. So let's do some examples. All right. You can have this. I'm going to give my little projector a rest here. This is getting hot. But I'm going to go through a couple of these examples that are on this page now. I'm just going to draw them and to save the projector and not give away the answer real quick. All right, the solutions are on the paper. I left them there because, again, I know it's pretty alien at first, so it takes some adjusting. Let me pull back the curtain here and turn on the light, and we'll go a little bit further here. All right. Ooh, I put my, you know what, I gotta get out my T-square. I like to use this just to sort of not have to erase so much. So, split the board here. And I'll keep myself limited to a certain space. Alright, so what we're going to do here for example 1 is we're going to translate, in all of these cases we're doing translation essentially. From Egyptian, ancient Egyptian to Hindu Arabic, right? All modern system, right? So if you see in sequence these characters, some clause, right? It's basically intuitive as long as you have the key. Let us translate this into the modern system, Hindu Arabic. Right. Remember, they just repeat the characters as many times as they need to, and it's basically adding. Right. You're going to add as many as you see here. What does a pointing finger represent? Right. Each one of these is 10,000. So you could write 10,000 plus 10,000 plus 10,000 if you want to be as brute force as possible. Right? Or if you want to be more fancy, right, you just do this times 3, right? A scroll, on the other hand, represents what? It represents 100. And since there are 3 iterations of it, it's 100 plus 100 plus 100. Or 3 times 100. A heel is 10, and the staves, all right, are just 1. So it'll be 1 plus 1 plus 1 plus 1, right? And you just add them all together. And it's a lot of pluses, okay? So 30,000 30,000 is the 10,000s place, so then there's a 3 there. 300, 10, and then 4. Should be 30,314. Okay. Again, once you get comfortable, if you want to be a little bit more efficient, go, all right, well, this represents 1,000, and there's 3 of them, so it's 3 times that. All right. But this is the maybe most intuitive way initially, right? Literally write out what it would translate to, and then keep, you know, how many iterations there are. That's how many 10,000s, how many hundreds, how many tens, how many ones. Okay. If you are going the other way, right, that is, if you're going to translate from the modern system, Hindu Arabic, to ancient Egyptian hieroglyphics, what we're going to do is basically write grouped sums. And here's the actual example, so I'll put this in blue again. What we would refer to as 1,203,462. All right, we're going to write out, sort of expand, right, as grouped sums. Right? Grouped are things that are put into parentheses. Right? So, according to place value. So here we have something in the millions place, right? Would be good to know, of course, the place values. Something in the 100,000s, something in the thousands, something in the hundreds, the tens, and the ones. This book has a tendency to refer to the ones place as the units, but same difference. Anyhow, we have one 10,000, pardon me, one 1,000,000. So I'm going to put that in its own little pocket. By itself, and in theory it would be added to the next thing, which would be 200,000. And then we have something in the 3,000s on the thousands category. So this is 3,000. And I'm going to add that to something in the hundreds place, which is 400. And I'm running out of space, so forgive me. I'm going to kind of write this adjacent here. There's something in the tens place, which is 60. And then there's something in the ones place, which is 2. This is just to get you started, you know. Yeah. When you get comfortable, you don't really have to belabor as I am here. But okay, this is just 1,000,000 rather than several million. We have a character already in Egyptian hieroglyphics that represents 1,000,000. Again, it's the astonished person. So for this first thing, we're going to use basically a person's body looking bewildered. A little bit like a bug. You know? Roach man, there he is. All right, now when we get to this sum here, this place value, it's 200,000, so technically it would be expanded 100,000 and then a second 100,000. Right. Comma, comma. All right. So in this instance, we have what symbol for 100,000? All right. I've already forgotten myself. It is the tadpole, right? So we would have 2 tadpoles, 2 Jesus fish here. All right. Then when you get to 3,000, remember remember, it's not just one, it's several thousand. So this is 1,000, 1,000, and 1,000, which in sequence would be lotuses. Fire flower here. And then, as you can see, you know, as we go along here, 400 is not just 100, it's several. So this is 100, 100, 100, 100. All right, the symbol for 100 is scrolls in profile. So, I'm gonna put that in blue. A scroll, a scroll, a scroll, a scroll. 60 is 10, 10, 10, 10, 10, 10, 10, right? Six tens. So because I'm running out of space, I'm just going to put it next to it, underneath here. Heel, 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 heel. And then it's just 2, right? Which is the sum of 1 and 1. So a staff and a staff. Now, as you kind of can get the point of why we don't use this anymore. This is fascinating, all right, and it is a revolution in thought, right, to have a symbol that represents a quantity, but it isn't efficient by today's standards because I couldn't even fit it on the board here. It is astonished person, 2 tadpoles, all right, 3 lotuses, 4 scrolls, 6 heels, and 2 staves, right, to represent what we have here, 1,203,462. Okay. Roman numerals are a little bit more concise, but they're, well, again, part of the reason we don't use them anymore is because they are inefficient by the standards of the day. And on that thought, let us look at that. We're going to translate from Roman numerals to Hindu Arabic. And here is the quantity MD CC L XX VI. All right, imagine the Super Bowl was up to that number, right? What we'll try to do is we're going to read from left to right, all right? If we see several of the same letter in sequence, we're going to add them, all right, just as we would. But we're going to also try to train our eyes to look at pairs here, all right? These first 2, all right, are basically 1,000 and 500, all right? The larger quantity is on the left side, and the smaller quantity, respectively, is on the right side. So we're just going to simply add these, and that makes 1,500 right off the bat. And then we have, after that, 2 C's here, which is just 200 to add to that. And let's see. An L is a 50 and a 10. And again, the larger quantity on the left, the smaller quantity on the right, we're just going to add these. So it's 60. Can you get away with doing the next one? Maybe, but I wouldn't do it anyway. I'd be very careful, especially now. If you've never added, again, if you've never been to Catholic school and you've never seen Roman numerals or anything like this, go slow, all right? Because it is a little alien. These 2, all right, this is 10, and this is 5, all right, and so this is going to be 15, and then you just have a 1 hanging on the end here, all right, plus 1. And now you would add the whole thing together. 1500 plus 200 plus 60. I'm going to put these in a column because it'll be easier to add them all. Side note, I say this to my students every semester, and I mean it. If you're going into elementary education, be a good sport, all right, or be a good teacher. Give your kids graph paper. I know that sounds kind of crazy to teach them to write things anal retentively in columns, but when it comes to adding or subtracting, they really need to. And if there's a reason that they make mistakes, it's because they have sloppy handwriting. So to sort of circumvent that problem, all right, give them the scaffolding, you know. If you give kids paper like this, when you're trying to teach them how to form letters in the English alphabet, right, why not do something similar when you're teaching them how to add or subtract, right? It sounds cuckoo, right, but neatness helps when you're teaching math. Anyhow, this is how you would collimate all things in the ones place, all things in the tens place, hundreds place, and thousands place aligned. So you could just do it intuitively, of course, but this would make it a little bit more obvious why, what is what. So 6, right, 7, 7, 1, 1776. Good year, right? Here's another one. Maybe a little bit more complicated. We're going to go from Roman again to Indo-Arabic. CMLXIV. Again, we're going to read from left to right. Generally going to add overall, but for those things in between, we're going to be looking at pairs. All right. Let's look at these two to start with. All right. C is 100 and M is 1,000. Right? And in this case, you see that you have the smaller figure on the left side, which means that we're actually going to subtract. All right. Meaning this is the relationship. It's really 100 from 1,000. Just be careful, there's no negatives here. That makes this what? 900 really, right? Plus whatever follows. Next one, 50 and 10 as a pair. That's more or less the normal situation where you have a larger quantity on the left and a smaller quantity on the right, so we're just going to add these and get 60. Right? And next pair. Right? We have 1 and we have 5. So in this instance, we have, as before, the smaller quantity on the left, so we're going to subtract. All right, that makes this 4. All right. And add them all together, and you get what? 964. Okay. Let's see, one more of these, and then we'll, no, 2 more actually. We're going to go the other way now. Are we on time? We're an hour in, that's so bad. We're going to translate from Indo-Arabic to Roman. And we have this figure. $439. Now, one thing that would be a good habit in general, and this is going to be especially important when we get to section 4.2 and 4.3, all right? Consider the character set that you're working with, all right? You have I's, you have V's, you have X's, L, C, D, and M. Right, so it's finite. But these are the characters that you are limited to using to express the same quantity. All right. All right. Start by trying to break into place values. All right, as a sum. So in this figure here, if it's 439, that's 400 plus 30 plus 9. Right? Right? We don't have in the character set something that would translate into 400. Right? We have a 1, we have a 5, we have a 10, we have a 50, we have a 100, we have a 500, and we have 1,000 to work with. Right? And the caveat, because this is part of the system, is that no more than 3 in a row. Okay, so we have a symbol for 100 that's close, all right, and we have a symbol for 500 that's close, but we can't put 4 C's like this, the C's in. We can't put C, 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 all right? We're not allowed to have 4, we're maximum 3. So basically, whenever you see a quantity that has a 4 in it, just know that you're probably going to subtract. So what we need to do is to translate this into a subtraction problem. We're going to have 100 essentially subtracted from 500. This is normally not allowed to be written in this order to assume a positive 400, but again, Romans don't understand negatives. So, and nor the commutative property. So this is essentially what we're going to translate to. We have a symbol for 100. So it's a C, and we have a symbol for 500, that's a D. 30, all right, we have a symbol for 10. So this is essentially 10 plus 10 plus 10, which would make this X, X, and X. Don't get drunk now. All right. And then we have this number 9 here, all right. 9, again, is not in this character set. All right, we have a 5, and we have a 10, and we have 1 here. We can't use 9 ones, as intuitive as that would be, right? Because a digit is like 1, right? 5 and another 4. We can't do that because 3 is the maximum. So what we would have to do really is, for the sake of efficiency, work with what we got, which is 1 minus, subtracted from 10. All right. So the symbol for 1 is intuitively an I. Right? And the symbol for 10 is intuitively an X. So CD, X, 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 I, X is what you would have in sequence. Okay. One more. Is a bit beyond the normal range. So we're going to work from Hindu Arabic again into Roman. And the quantity we have to work with is this, 12,345. All right. So here's our character set to work with. We know that we're not allowed to use more than 3 of the same character in a row. And we're going to attempt to break this up into place values. So, let's see. This would be 10,000 plus 2,000 plus 300 plus 40 plus 5. Now remember, when we have something that is much greater than 1,000, we use bar notation. So in this case, what do we have here? We have 10,000, right? And that is well beyond 1,000, right? We can't put 10 M's in sequence, even though that might be tempting. That would be a little bit too much like ancient Egyptian hieroglyphics, and it is a lot less efficient. So what we can do is maybe recombine these. So we have 12,000. All right. And we'll translate this into Roman numerals. And this part will be that part that is times 1,000 using bar notation. All right. How do you express the quantity of 12 just by itself? All right. Well, it would be 10 plus 2, and then that times 1,000. 10 is x. And 2 is 2 i's. And since it's 10,000, 12 times 1,000 with a bar over the group here implies that it's really 12,000 rather than just 12. Okay. So in this instance, we've consolidated these two because it's more efficient to write it this way. Right? The other things that follow it, this is 100, 100, 100. There's 3 of them, that's the maximum, but it's fine. So this would be x, x, and x. 40, you'd have to subtract 10 from 50, which would make this, let's see, another x, but an L. Oh, I'm sorry, what am I doing? These aren't x's, those are c's. Shame, shame. C, 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 for 100, 100, 100, right? This is a 10, and this is an L, right? So XL, t-shirt, there you go. And then the last character is just a 5 here, which we have as a B. Okay. So bar notation over X, II, to make it 12 times 1,000 to really express this quantity like so. All right, 3 C's for the 300, the subtraction of 10 from 50 to express 40, and then a regular V for 5. Okay. All right. Now let me put my projector back on. We're going to go into traditional Chinese characters now, and that warrants clarity. Just a second. Wake up, computer. Okay. Alright. The information that is useful or good to know for traditional Chinese characters is the following. It is similar to Hindu Arabic in that there are symbols for the numbers 0 through 9. But then there's also powers of 10 beyond that. So there's a symbol for 10, for 100. Again, I would definitely encourage you to print this. Right? As a person who is not grown up in the East, right? This key would definitely come in handy. Here you see the symbol for 0, Ling. All right, this is actually my favorite. But I love this because it's the one thing that I know the name of, Ling. I might be mispronouncing it, but phonetically L-I-N-G with an accent mark is 0. Right, looks like a little person's face. Right, and that's why it's easy for me to remember. The other things that follow it, 1, 2, and 3, they're very intuitive, right? It's just like Roman numerals. It's just written horizontally versus vertically. All right. 4, 5, 6, 7, 8, 9. There are the character set from 0 to 9. Right? And then there are unique symbols for the powers of 10, 10 to the first, 10 to the second, 10 to the third that we have here. Okay? So it's a little bit hard to write without a brush, but we will muddle through. All right. Anyhow, we have those symbols. This is the example we have for a multiplicative system, so we're going to mostly be multiplying and technically adding by default, because what is multiplying but adding efficiently? There is a symbol for 0, again, ling, all right, good to know, all right, which makes it capable of more complex math than just, adding or subtracting, really. Quantities are written vertically, all right, so you're going to stack them. Now, usually what the case is that things are in pairs, so when you see a pair, a genuine pair, the top would be the character that is from 0 to 9, all right, something that is expressing this character, and then what you multiply by, right, the power of 10 that is underneath it, all right. So think of that as basically being the model that will be emulating or translating. All right. The ones, or the otherwise referred to as units place, are never multiplied. So if you have something in the ones place, all right, it would be unnecessary to multiply 1 by 1, So you just have a single character in the ones place. For things like 11 through 19, you would see again a pair, all right, but it would be understood as the bottom is the ones place, and the top is instead the tens place. So it's always going to be 10, the character for 10, which looks something like a cross. All right, and then the additional character that is 1 through 9 immediately underneath it. Right? There's really no multiplication in a case like this. Stacked but not multiplied. Now, what to do when you have situations where we have quantities with zeros, all right? For any amount of zeros that are between non-zeros, this is understood as being between non-zeros. The one symbol for ling is sufficient. You don't have to do multiple iterations of that character, all right? If you have a 0 on the end of a number, we would consider it the far right, all right? Then you don't even have to draw ling, all right? You just leave it alone, all right? It's unnecessary to incorporate that. Nothing is nothing, so there's no reason to have a symbol for it. Okay? Oh, let me just add one other thing too. The one symbol is sufficient, which means, all right, there is no multiplier necessary either. Right, just the symbol for 0 is fine, right? And there's no extra lings, right? Okay. Let's do some examples of translating those. I'll turn this off for a moment. Spare the bulb. I've gotten plenty of hours out of it so far, but I worry sometimes that I'm going to burn it out. Okay. And again, just to confine myself, we're translating something from Hindu Arabic into traditional Chinese characters. Right. If we'll start with what is familiar. The number 538. Yeah. Remember, we're going to stack things. We're going to break into place values. But we're going to do it stacked instead of more or less horizontally. So if you have, I'll put it over here just to reiterate. 538, let's more or less, I don't want to say factor because that would imply multiplication in a place that hasn't occurred. I'm trying to get rid of some glare, sorry. And I don't want to cast a shadow either. We have something in the hundreds place, it's 500. We have something in the tens place, we have 30. And we have something in the units or ones place, which is what I was always taught to call it, 8. All right. So far so good, we're just stacking them. All right. Now, this is the ones place, right? So we really don't need anything but the character itself. We could do that automatically. And humor me, I'm going to translate that using my key into the appropriate symbol. So we have, I apologize, I don't know the name of it, how to say it in the traditional way. But I'm going to draw what is something of a mustache here, mustache, all right, for 8. All right, because this is the units place. So using a chisel tip marker might help a bit. Forgive me for my lack of practice here. It's a bit of a struggle, right? This is supposed to be an 8, I swear. Do forgive me, anyone who is of Chinese ancestry. All right, now as for when we get past that into the tens place, all right, now we can employ the strategy from before, where the top is the character from 1 to 9, and the bottom is something that you multiply by a power of 10. All right, so 10 or 100 or what have you. So if we want to express the quantity of 30, right, it would naturally be 3 times 10, right? We have a symbol for 3, which is very intuitive, all right, which is like Roman numerals, it's 3 lines, but stacked. All right. Stylistically, I'm probably not doing it any justice, because again, it really should be, if you're going to do this traditionally, you should be using a brush, all right, not a chisel tip marker, all right, and certainly not holding it this way. But here you have basically 3. And then you have the multiplier underneath it. Now, just to give it some distinction, I'm going to put the multiplier in red. The symbol for 10 is more or less a cross shape. So something like that. And now, just because I need the space, I'm going to clear this up here. And we're going to do the same thing here. We have something that represents 500. So that would be, the top is the figure from 1 to 9. So 5 times 100 would reasonably be 100. Let me just scoop this up a little bit because I'm taking up too much space here. 5 times 100. And I'll translate that. The traditional Chinese character for 5 looks something like this. So imagine a stack of 3 as before, but some additional distinct strokes. Okay. Don't feel bad if you've never done this before and you make a mess as I am. Right? You only get better at it if you do it a lot. So this is supposed to be 5. And now the multiplier is, I'll put again in red here just to make it obvious that that's what its job is. So a stroke, and something like that. And in tandem then, all of these things grouped together, and my pickle here is the quantity 538. All right. 5 times 100 plus, by default, 3 times 10 plus 8. Okay. That's fun, isn't it? All right, especially if you're like me and you don't have a lot of experience. I mean, I've taught this class before, but you know, how often do you write in traditional Chinese characters in the United States? This is actually quite enjoyable, all right? And if, again, we're doing it justice, I would be using a brush rather than the chiseled tip marker on paper. And hopefully get better at it. Now that is converting from Hindu Arabic to Chinese. Let's do a couple of these to illustrate. We'll do that again. The quantity is 7,080. Now notice in this instance you have zeros involved here to illustrate the point from earlier. So we are going to take this and we're going to try to break it up stacked first. So I'm going to put it off to the side here. I may have to erase this, so let me free up a... I don't want to get myself in trouble here. 7,080. We have something in the thousands place, so I'm going to start with 7,000. We have nothing here for the 0 really in the hundreds place. We have an 80, and again we have a 0 on the end. This is a situation where we have zeros between, and we have a 0 on what would be the far right on the end, and how we'll deal with that. Right. The ones place would probably be better to start in this case, because that doesn't require any grouping. Right. So no group, no multiplier. The symbol for 0 would be ling, but because it is on the very far right, right, leave blank. In the case of having it on the end, right, it becomes unnecessary to draw that. When you get to now the tens place, all right, we're going to bring, I don't want to say factor, but we're going to fracture this. So you have essentially 8 times 10. And then the character to 8, and then its multiplier of 10. And then we have the situation where we have a 0 between, all right? Now, because it happens to be between, we will put, it doesn't require a multiplier either. We're just going to use the one symbol for ling, which I'll put in blue. And although this is my favorite one of the set, I'm still not quite adept at it. But the way I have convinced myself to learn to do this is that it's something like a face. a person's face wearing something of a hat, if you will. Right? And I don't mean that disrespectfully, I'm saying that because I appreciate it. Anyhow, wing 8 times 10, and then we're leaving the bottom blank for the ones place. Lastly, we have 7,000, so we have 7 times 1,000 in this case. The symbol for 7 looks something like our version of a script T here. I'm stylizing it a bit more than I should, as it isn't actually T. Right? But that's that. And then the multiplier that we need for 1,000 is very much like 10, but with an extra slash brush stroke. So and since again we're not using anything for the 0 on the very far right, this would be the stack. 7 times 1,000 plus 0 technically, wing, which might have, it's very hard to see because of the faintness of this, but there might actually be extra lines here. To me, it's like a little person's face, right? Which makes it easier to remember for that reason. Plus 8 times 10, right? And that's sufficient. If in the case of the subsequent problem, we had something like this, 7,008 as opposed to 7,080. There's no 0 on the end, so you don't have to worry about it. But when you're fracturing this, right, it's 7,000, 0 in the hundreds, 0 in the tens, and then 8. Right, to get you rolling here. We would use the 1 symbol in the ones place here for 8. I'm getting better at that, I hope. We don't have to use multiple zeros, right? We just use the 1. Imperfect, but forgive me, please. And then more or less the same quantity up here. So, multiplier. Just make that distinction, right? Zeros in between, however many there are. You do not need a multiplier for zeros, right? 0 times anything is 0. But you do account for them when they're in the middle, right? So you put the symbol there. When they're on the end, they're not necessary. Okay. One more slide and then we're done. Turn the projector back on to summarize. computer. There we go. I'll turn off the light again. And my computer will look up here. Okay. Last from this slew of numeration systems, we have Ionic Greek. All right. Now, Ionic Greek is the predecessor to Classical Greek. Right. So, I guess it's probably something like I don't know if Minoan is a little bit too far back in time. Ionia was a place in Greece, obviously, but this alphabet actually had 27 characters, right? At least to the sake of numbers. That would be 24 that would still be used, but 3 that are now obsolete. Right? Again, you would definitely want a key, and in this case we'll be referring to this table, table 4.4 from section 4.1. Right. If you count these, there are 27 of them total, but that's because there are some things like this down here. I'm reading it backwards. Sampi, right? That is no longer used. Right? It's an interesting symbol. Right? Many of the other ones are the same. Copa is another one, I believe. With the where you see the asterisk is probably the obsolete character here. Digamma. Okay. Now, it probably, especially as a person in college, you will have heard these referred to before: alpha, beta, gamma. All right, and they would translate to AB, right, and so forth. A, B, C, you might say. I think gamma was G, but I mean, like delta is definitely D. So I want to say that this is A, B, C, D. Right? Epsilon is E. Anyhow, just be aware you have 27 characters to work with. They are letters. The reason it's ciphered is they are letters used to represent numbers. All right, letters used to represent numbers rather than having unique symbols as we do in the Hindu-Arabic system. Right. Now, this is going to entail mostly adding, but also technically multiplying. They have the same situation as with Roman numerals, but instead of bar notation, there's a superscript. So the Greek character iota, which would look something like that, sort of a superscript I. That's supposed to be a caret symbol. Iota. In front implies that the character is multiplied by 1,000. Okay. They are again absent the symbol for 0, but, and in one way it's practical, in another way it's not. There are characters from 1 to 10. And then there are multiples of 10. So there's a character 420, there's a character 430, there's a character 440, and so forth. And there happens to be multiples of 100 as well. A character for 100, a character for 200, 300, 400, all the way up to 900. Which means that when you get to 1,000, you're going to have to, unfortunately, start using the superscript iota, right? Now, what would have happened is if you were going to distinguish this from an actual word, is something of an apostrophe would be used to indicate that this is a number, not a word. Okay, so those are basically the ground rules. Let me turn this off, as it isn't necessary now, and we'll do the last examples. And what we will do is these 2 examples, and then we're done. We're still translating. So from Ionic Greek into Hindu-Arabic. And then we will do an example of Hindu-Arabic into Ionic Greek. Okay. Because it is ciphered, all right, again, letter representing a number rather than just a letter, or having a character for just a number. Think of it as a code, right? One needs the key, otherwise you can't translate. Right? It requires a lot of memorization, but once a person does, that's what makes it efficient, that it is familiar. All right. So if you had what is referred to as tau, Greek alphabet tau, which I'm stylizing here, but more than I should, and pi, and then epsilon. This is a little bit more familiar to me because I've been in school for so long. These translate to specific values which you are going to add. There's no superscript up in the front, so you're not multiplying by 1,000. You have some numbers that are just going to be combined here. So if you look again at the table, right, look for tau. Here's tau, it's 300. Pi, everybody's favorite is pi, right? Would be mine as well. Pi is 80. And epsilon is the fourth figure, so 4. So that means literally you're going to add 300 to 80 to 4, right? Which makes this 384 intuitively. Okay. Now if you're going the other way, it's a little bit more tricky, but it's similar in the approach as before. You're going to break it up into place values. So here's the figure. 1,654, again, break into place values. So you have something in the thousands place, right? You have something in the hundreds place, you have something in the tens place, and you have something in the ones place. In theory, these would be added, but when we're translating in this direction to Ionic Greek, you don't have to actually do the adding. Right? Now remember, 900 is the maximum, so this being that we have something that's 1,000, we need the symbol for basically 1 times 1,000. So we need the symbol for 1, which is itself alpha. So let me put this in red just to give it some distinction. Alpha, which again I am stylizing more than I should. All right, and then because we have, it's just that is accounting for the digit of 1, we have to put a superscript up in front. So the superscript is the 1,000 portion of this. To imply that is iota. It's basically an I. All right. Now when you get to 600, there's a character specifically for 600. All right, and if you look here, as counterintuitive as that might be, it's chi. C-H-I is pronounced chi, not chai. All right. So chi, and it is a capital, I believe. No, maybe not. This is chi. Right. There's a character for 50, which if you look is actually epsilon. Is that right? Yes. Oh, Dodo, I'm sorry. Epsilon is 5. Sorry. From earlier, I'm sorry, it's not a 4, it's a 5. 50 is, where is it? Oh, new, which is something of the V shape. So something like that. This would probably be done with like a, if not a brush, then something like a feather quill. And 4 is delta. Right? These are lowercase delta. So alpha with the superscript iota to imply 1 times 1,000, chi for 600 because it exists, nu for 50, and delta for 4. All right, just to correct myself from before, epsilon is 5, not 4. Okay, and that is that pickle here. All right, I believe that is it. All right, that's a lot to digest anyhow. So, since we are now finished with section 4.1, let me just close by reminding you, all right, what you want to do essentially for homework is, 1, make sure that you establish a MyLab account so that you can do the assignments you're primarily responsible for. And then 2, work on section, there's a prerequisite actually. Prerequisite and section 4.1. Okay? The prerequisite for chapter 4 is systems of numeration. Okay? All right. Thank you folks for sticking with me. I'll see you again tomorrow. All right? Be careful out there.